Welcome to Math 1314. This is section 3.6. We're looking at polynomial and rational inequalities. So, in part 1 here, we are given a graph. So let's take a look at this graph and see what we see about it. So first off, here's the x-axis. So this is the part of the graph where if the graph touches the x-axis, so touching it at 3, touching it at the origin, touching here at -5, that's places where f of x is 0. So if the graph is above the x-axis, then that's the place where f of x is greater than 0. And if the graph is under the x-axis, that's the place where f is less than 0. So the question is, well, where is that going on? Well, let's see. On this part, from minus infinity to -5, on this piece, where's the graph? It's under. So from minus infinity to -5, f is under. Alright, from -5 to 0, the graph is over the top. And then from 0 to 3, on this piece, the graph is under the x-axis, so f of x is less than 0. Now, if we want to include the 0 in the process, so this is f of x less than or equal to 0. Then notice how before I had parentheses 0 to 3. If you include 0, you would then include the 0 and the 3. Let's see where else. From 3 to infinity. On this piece, the graph is going up, so f of x is greater than 0. And if you wanted f of x greater than or equal to 0, you would include the 3 where it touched the x-axis. Alright, and then the rest of this would be just filling in those answers. Alright, so looking at question 2 here, what do I see about this one? Alright, well, here's the x-axis. That would be places where f of x would be equal to 0. Well, the graph never touches the x-axis, so it's never going to be 0. If here's the x-axis, then the graph seems to always be under the x-axis. And so f of x is less than or equal to 0 or less than 0 everywhere. On the whole number line, the graph is always underneath the x-axis. And so where is it above the x-axis? Nowhere. And so it would be the empty set. There's nothing in the solution set. Alright, now in question 3, we actually begin solving some inequalities. So we have 16z squared minus 25 less than 0. The way we solve these is first we set it equal to 0 and see what makes it equal. So in this case it is factorable. We set each piece equal to 0. And that would give me 5/4 and minus 5/4. I take those numbers and I plot them on a number line. So here's minus 5/4, here's a positive 5/4. Now I plot them with a open or closed dot, simply depending upon the inequality in the problem. So ours does not have an equals, and so these are open dots. Alright, once we do that, once we plot our solutions with open or closed dots, we then pick a test value from each of the pieces on the number line. Doesn't matter what number you pick, just make sure it's easy to calculate with, and it does live where you're picking it. So for example, here's minus 5/4. I couldn't say, oh, I'm going to pick -1. Well, -1's not here. -1 would be on the inside. So just make sure you're actually picking numbers that are in that region. And now we test them out. Plug in -2. So -2 squared is 4. 4 times 16 is 64. 64 minus 25, would that be less than 0? No, it's not. So I don't shade anything. I try the 0. So this would be 0 minus 25. Is that less than 0? Yes. And so then we would shade all of the stuff in the middle. If you try the 2, 2 squared is 4. 4 times 16 is 64. 64, is that going to be less than 0? No, that's not true. And so the part that works is minus 5/4 to 5/4. All right, in question 4 here. Now, we again will set it equal and start solving. So first I distribute the 3. Now I'm going to move everything over to one side. So a minus 3x, a minus 9. Combining like terms, I've got 6x minus 3x, so that's a 3x. Now I need to solve this quadratic. Well, it does factor. Let's see, 2x times x, 2x squared. Minus 3 times 3 is a minus 9. I get a minus 3x, a positive 6x, so I do get a plus 3x in the middle. And now if I set each piece equal to 0, I would get 3/2 and minus 3. I plot them on a number line. Why are there open dots? Well, because of the inequality. And so now I'm picking some test numbers. Let's see. -4 is to the left. 0 does live in the middle, and 2 is on the right. And so again, I'm just plugging it back into the original problem and seeing if it produces a true statement or not. So for the -4, I'd have 32 minus 24. Is that less than -3? No. If I plug in 0, is 0 less than 9? Yes. So over here on 0, all of this gets shaded in. If we try the 2, 2 squared is 4. 4 times 2 is 8. 8 and 12 is 20. Is 20 less than 15? No. So the part that works is -3 to 3/2. In question 5, all right, question 5, we set it equal first. Solve this problem. So I'm moving the 5y to the left. It does have a common y I can factor out. I set each piece to 0. So that gives me the 0 for the y. What makes this piece 0 is a 5, and so I'm plotting them on a number line. Because the inequality has an equals, these are closed-in dots. And so now I pick some test values. -1, 1, and 6. -1 squared is 1. Is that bigger than -5? Yes. So everything off to the left forever gets shaded. Try the 1. Is 1 bigger than 5? No, that's not true. So nothing is shaded. I try the 6. 6 squared, is that greater than 30? Yes, that is true. So I shade the right, and so I get everything on the left, including the 0, everything to the right, including the 5. All right, looking here at question 6. So first I set it equal. All right. I try to get everything on one side, so I'm going to move the 3t to the right. I'm going to move the 5 to the right. Now, my hope was that it factored, but it does not factor, which is not a great fun thing to do. So we don't panic. We do have the quadratic formula. So minus b is 3, plus or minus b squared minus 4 times a, which is 10, times c, which is a minus 5, over 2 times a, which was 10. And so 4 times 10 is 40. 40 times a minus 5 is 200. And so we get minus 3 plus or minus square root of 209 over 20. All right, now that's not a number. I know how big it is, so I made some rough estimates to get some decimal numbers. Why did I do that? Well, I did that because I need to figure out how do I pick my test numbers. Why are they open dots here? Well, they're open dots because our inequality did not have an equals. All right, so I'm going to pick minus 1. I'm going to pick 0 and 1 and simply plug it back into the original. 4 minus 1 is 8 bigger than 10? No. Is 5 bigger than 0? Yes. Plug in the 1. Is 2 bigger than 10? No. So the part that works is the stuff in the middle. And then now I put back in the radical notation for the two endpoints. All right, question 7. Life gets a little easier here. We set it equal. Move the 16 to the left. It does factor. I get that y is plus or minus 4. Plot them on a number line. They are closed dots because of the equals. Pick some test numbers, minus 5, 0, and 5. All right, is 25 bigger than 16? Yes. Is 0 bigger than 16? No. 25 bigger than 16? Yes. And so I get the stuff on the left, including the minus 4. I get the stuff on the right, which is everything on the right, including positive 4. All right, so now question 8. Now in question 8, I don't have to multiply this thing out. All I need to know is how does it chop up the number line. So what makes this piece 0 is minus 5. What makes this 0 is 3. And what makes this 0 is 5. So I plot all three of those numbers on the number line. And now I simply pick one test number from each region. Minus 6, 0, 4, and 6. All right, and then I plug all these things in and see what works or not. Now there's a bit of a trick here in that I don't really care the exact number. All I care is it greater than 0 or not? Well, this first one would be negative or minus. This is minus. This is minus. Why am I saying minus? Well, because minus 6 minus 5 is minus 11. So if I've got a minus times a minus times a minus, can that ever be bigger than 0? The answer is no. If I try the 0, I would get a positive, a negative, and a negative. So that's really a positive times a positive, and is that bigger than 0? Yes, that's why that's shaded in. If I try the 4, all right, that would be positive, that's negative. The product is not going to be positive, so that's a no. And the last one, I've got positive, positive, positive. Product is positive. So that's a yes, and what works then is -5 to 3, union all the stuff on the right. Alright, on part 2 of section 3.6, we are looking at solving rational inequalities. Now with these, it's a similar kind of process, but to start off, the important part here is I need a 0 on the right and a single fraction on the left. If I don't have that, I need to make a 0 and often make a common denominator. But we have that here in question 1. So I set the top equal to 0. 8 minus x is 0, which gives me x is 8. I set the bottom to 0. X plus 9 is 0, and I get x is minus 9. When I plot them on the number line, the answer to the bottom is always an open dot. Again, whatever makes the bottom 0 is always an open dot. It's not included because if it were, it would make the problem undefined. The 8 came from the top, and the top gets open or closed depending upon the inequality. Well, ours has an equal, so it's there. Now the rest of the problem is similar to what we just did, and that is I pick a test number from each part and I try it out. If I try the minus 10, let's see, 8 minus a minus 10 is 8 plus 10 is 18. Minus 10 plus 9 is minus 1. 18 over minus 1, is that bigger than 0? No. If I plug in 0, I would get 8/9. That's positive, and that is greater than or equal to 0. And if I try the 9, I'd get a minus 1 over 18, and is that greater than or equal to 0? The answer is no. So what works? Well, all this stuff in the middle, and that's minus 9 to 8. 8 is included. That's why there is a bracket. All right, question 2. Do have a 0 on the right, single fraction on the left, and so I set the top to 0. That gives me x is 2. I set the bottom to 0. That gives me x is 0. Let's see, the bottom answer is 0. That's always open. The top answer was the 2. Now the 2 gets open or closed depending upon the inequality, so it's closed. Some test numbers. Let's see, left of 0 is minus 1. In between 0 and 2 is 1. And bigger than 2 is 3. Alright, so plug them in. See if it gives me something that's true or not. Well, in this case, minus 1 fails, 1 fails, and the only thing that works is 3. So therefore, the stuff that works is only 2 off to the right forever. All right, question 3. Let's see, 0 on the right, good. Single fraction, yes. And so I set the top to 0. That's a quadratic to solve, but it does factor. And I get the numbers of minus 5 and 4. So minus 5 and 4. Why are they closed? Well, they came from the top, and the top reflects the original. What about the answer to the bottom? Well, that's when P is 1. Bottom answer is always an open dot. So now I just have 3 numbers to pick, 4 numbers to pick and try. So I've got minus 6, 0, 2, and 5. We plug them in and see if it gives me something true or not. For the minus 6, is minus 1/7 bigger than 0? No. For 0, is 20 bigger than 0? Yes. Therefore, shade it in. I try the 2. Is minus 14 bigger than 0? No. And if I try the 5, is 10/4 bigger than 0? Yes. And so when I look and see what works, we get minus 5 to 1, but they're not included. Oh, they are. Minus 5 is included. And so this would be a bracket there, not a parenthesis. So minus 5 to 1, and then 4 to infinity. 1 has a parenthesis because it's not included. All right, let's see our last one here. Now, don't have a 0. Need to fix that. Well, I make a 0 by moving the 1. I have a 0, but now this is not a combined single fraction. I get a common denominator. I rewrite this 1 as 2c minus 9 over 2c minus 9. All right, the minus gets distributed to both the 2c and the minus 9 over the common denominator. And so I end up getting minus 2c plus 14 over 2c minus 9. All right, set the top to 0. That's pretty easy. I get c is 7. That's an open dot because of the original inequality. What makes the bottom 0? That's 9/2. That's an open dot. 9/2 is really 4.5. So when I come and I pick my values to try, I can pick 0, 5, and 8. Plugging them in back into the original, I see the first one, no. Second one, yes, 5 is bigger than 1. That's true. And when I try the 8, is 5/7 bigger than 1? That answer is no. And so we get as a final answer 9/2 up to 7.